So let me copy it. The integral from natural log x everything squared divided by x dx. Okay, perfect. So remember, the substitution, the idea is to make the integral simpler and always look at something that is more difficult. What part is more involving? Not this, but this, right? It's a function inside raised to the second power. So my thinking is to denote this, but only if du is in the problem. Minor a constant, plus or minus a number. I can always make that up. And yes, it is. Du is in the problem. Dx over x, or 1 over x times dx, is the same thing. So this is my du, and this is my u squared. So I simplified it tremendously. So what is this? Is the integral from u squared du. It couldn't be easier, right? So the substitution really worked. So this is u to the third over 3 plus a constant c. And now because it's indefinite, I must present the answer in the variable that was given to us. So now I have to go back and replace u by natural log x. I have to put power 3, divide by 3, plus a constant c. We should choose as many different types as possible. They're really helping. Before we look at the next problem, any questions on this? Okay, so let's go back. So this was 25. Anything else from the indefinite? Well, 29 caught my eye, for example. In 29, we have the integral from x minus 1 over x squared, and then x squared plus 2 over x power 5 dx. Okay. Can anyone suggest here a substitution?
What's the power 5?
What's inside the power 5? That's the problem. Exactly. What's inside the power 5? Power 5 is friendly. If I have x to the 5th, that's it. I can't have anything, right? It's simple. But this is the issue. So I'll say let u be x squared plus 2 over x. This is the right substitution only if du is easy to determine and it's somehow in the problem. Because if it's not in the function, I may have some difficulties here. But there is no problem because I have 2x minus 2 over x squared, and I will factor out the 2. So 2x minus 1 over x squared dx. Yay! Who cares about this? Plain and simple. Nobody cares about it. It's a tiny number. I multiplied by 2 and divided by 2. So I have to observe that. I have to notice that the factoring of the 2 is crucial here to see that x minus 1 over x squared is here. So now this piece, and this piece, all these three make up the du. So then I have 1/2 in front. I have u to the 5th du. And again, it reduced the original integral to nothing. So the substitution was really crucial here. I'm not going. You can say, yeah, okay, raise this to the 5th power. You're going to get 6 terms because it's a sort of a binomial, but 2 terms. Distribute. It will take me forever to do that. So this is my problem. Here, this was my problem because it was a function raised to the second power. If it's just x or u to a power, that's no problem at all. Something like this is a problem. If it's no power, it's no problem. But if it has a power like 5 or 4 or whatever, it's a problem. So again, the 2, the x minus 1 over x squared, and the dx, these 3, don't cross them out. I'm just making a point. These 3 pieces are here. The 1/2 stays, and this is the u to the 5th. And again, it cannot be easier, right? So it's 1/2 u to the 6th over 6 plus a constant c. Of course, I'll multiply the denominator, so 1 over 12. I have to go back and replace u with x squared plus 2 over x to the 6th power plus a constant c. So always with your mind's eyes, or with your eyes if you want, decompose this function or look at this function, inspect this function. This is, okay, well, x minus 1 over x squared is not the nicest, but this is the problem because it has power 5. Because if I only have x to the 5th, I can distribute it here and I'm done in a blink. But no, I have x squared plus 2 over x. I know I talked too much, sorry. Good. Anything else from indefinite?
Can I do 31?
You said 31. Very good. 31. In 31, we have the integral from, I think it's e to r. I'm going to change everything to x because it's e to x and everything to 3/2 and dx. Okay, perfect. Can anyone give us an idea of what would you think? You can, I'm using u. You can use t, you can use z, you can use w, you can use whatever you want. Y. You cannot use x though. So based on what we just discussed, can anyone give us an idea on what would be the, it's okay if you're, you embark on a,
E2 plus 3 e to x.
very good. That's the problem. This is the problem. Whatever, 2 terms to 3/2, my goodness. That's the problem. Now, I don't know. It depends on whether du is in the problem. Because if du is not in the problem, or it cannot be slightly fudged, if you want, then I'm not on the right track. I have to find something else. So what will be the du for this function? Anyone? Can anyone give us the du for this?
3e to the x. And then you go divide by, or times 1. Wait, that's it, right?
Okay, let's go back. Let's look at this du. Aha.
Oh yeah, dx. Yeah.
Please understand it. Without dx, this is not du. Good. Okay, do I have it? Yeah, of course I do. Oh, who cares? That's a little thing. If it's x or something else, no, it's not a little thing. But if it's just a constant, just a poor number, yes, it's nothing. So 3e to the x dx, 3e to the x dx, du, u to 3/2. Again, the whole thing looked awful. It reduced to nothing by simply using the correct substitution. So this is 1/3 u to 3/2 plus 1, which is 5/2, divided by exactly the same number plus a constant c. I have to flip. So I have 2 divided by 15. I have to replace u by 2 plus 3 e to the x, everything to 5/2 plus a constant c. Please try to get used to the differential. We used it in chapter 4, and we're using it a lot now. Any questions on this problem, anyone? Okay, I'm sharing my screen. Do we want to look at anything else from the indefinite? Anyone else? Anything else? Yes? No? Um, 51 caught my eye. So let's look at 51. The integral from 1 plus x over 1 plus x squared dx. Well, this is slightly different. And here is why. I look at the numerator and the denominator, and if I use the denominator as u, I will never get this to work. But if I notice that this fraction can be written like this, dx. So in other words, what I'm saying is, think of the denominator as one term. And the numerator can be written, so if I have 1 plus x over a, I can write 1 over a plus x over a. And this is what I'm doing for this problem. I take 1 over a plus x over a. Why am I doing that? Is because you'll see in chapter 7, in Calc 2, we have a method called partial fraction decomposition. Partial fraction decomposition. This is a very simple example of that. We're not going to go into it. It's a big theory, a long theory behind it. So then I will continue. This is very simple, right? This is arc tangent x plus the integral from x over 1 plus x squared dx. And now the substitution will work on this. Because now the denominator is the problem, because it has two terms. And you can say, but you didn't say that here. Right, because I noticed that this can be split like this. This is very simple because arctangent prime is 1 over 1 plus x squared. That's done. And we can work on this with a substitution. And the substitution, of course, will be the denominator. So let u be 1 plus x squared. Of course, du equals 2x dx. All I have to do is fudge my number, which nobody cares. No, there is no change. If I multiply by 2 and divide by 2, who cares? I didn't change anything. So, and then this will, oops. So this will continue here as arctangent x plus 1/2 the integral from, so 2x dx, 2x dx, all this right here is du over the denominator, which is u, which is again is very simple. So this is arctangent x plus 1/2 natural log of the absolute value of u plus a constant c, and I have to go back. Since 1 plus x squared is always positive, I will omit the absolute value. Otherwise, I cannot. So then the final answer is arctangent x plus 1/2 natural log in parentheses 1 plus x squared, or x squared plus 1 plus a constant c. And again, you can always say, show me that this is that, and you can always differentiate and you will get the same thing. What is the same thing? What? This. When you differentiate all this, you have to get this. If you do not get this, Something is wrong here. Any questions?